Nous allons avoir une personnalité exceptionnelle. Vous savez que j'ai eu la chance de bien connaître de grandes personnalités scientifiques. Il se trouve que pour un film pour Canal+, qui va sur Dieu et la science, qui va être diffusé en avril prochain, j'ai interviewé cet été 10 prix Nobel de physique, et je peux vous dire qu'il est de loin celui qui, je pense, sur ce sujet-là, a les choses les plus profondes à dire, car il a profondément réfléchi sur le fait de ce qu'est un grand scientifique et aussi un croyant. C'est la première fois qu'il vient au Maroc, et donc je vous demande une ovation pour le prix Nobel William Phillips. Merci. Merci.
Well, thank you very much. Thank you very much, Jean. Is it working now?
No, micro.
Okay. Now it works? Well, thank you very much for that kind introduction. I'm going to talk to you about quantum science, reality, and religion, and I emphasize that this is one physicist's viewpoint. So I don't claim that anything that I'm going to say is universal among physicists, even among atomic physicists, but it represents my perspective, and I hope that it will be a useful point of departure for discussions. Now, I want to specify a few things about myself. I am not an expert, or am I particularly original in the study of science and religion, and I'm very grateful to many mentors, some of whom are pictured here, who have taught me many things and given me important perspectives about the relationship between science and religious faith. I am an expert in some small areas of quantum science, and I've shown some pictures here of the kinds of things we do in my laboratory, which I will not be talking about, but I guarantee you is incredibly interesting. We, in my laboratory, make gases of atoms so cold that they're really the coldest things that have ever been anywhere in the universe, as far as we know. Within 1/1000th, 10 to the minus 9 degrees of absolute zero. But that is not the subject of today's talk. I'm going to address, to begin with, what is often a central question for people. How is it that a serious scientist can be a person of religious faith? And first of all, why do people even ask this question in the first place? Well, one of the reasons is that there are a number of historical myths about the relationship between science and religion. Now, when I use the word myth, I don't necessarily mean a story that is not true. What I mean is a story that has power, that has the power to define us and to define our perspectives. And the story that I think everyone knows about Galileo and the Inquisition, where Galileo was forced to recant his view that the earth went around the sun instead of the other way around. But even though he was forced to recant this Copernican theory, which he was completely convinced of, he did not take this as an opportunity to give up his religious faith. And throughout the history of science and religious faith, history is full of people of Muslim faith, Christian and Jewish scientists who were very serious scientists, pioneers in their field, but also people of sincere religious faith. Ibn al-Haytham, who's known in the West as Al-Hazan, was the father of optics. I'd love to tell you about the amazing things that he did, but corrected a lot of misconceptions about optics, about vision, and he also is credited with being the originator of the scientific method. Hundreds of years before Roger Bacon did something similar in the West. A man of religious faith. Isaac Newton, who gave us classical mechanics, who gave us the first theory of gravity, was also a person of religious faith. I am told that he spent more time studying the scriptures than he did studying science. So this fact that there are people of religious faith who are serious scientists who have changed what we believe about the way in which the world works through their scientific investigations is something that has continued and has been a common experience throughout history. So we have many scientists today who are people of religious faith. I am one example, and there are a number of examples sitting in the front row of this auditorium. Of course, there are many scientists who are not people of religious faith. But scientists are people who devote themselves to the understanding of the natural causes of the phenomena of the universe. And many scholars have contended that religious thought, that religion itself arose to explain the unexplained phenomena of nature. So if scientists are dedicating their lives to natural explanations of these things that some people say gave rise to religion in the first place, then why is it that so many of these explainers, of these scientists, maintain their religious faith? Some years ago, the Templeton Foundation funded a study to address the question. They asked various people to write essays addressing the question, does science make belief in God obsolete? Well, you can't read any of the things that people said, but perhaps you can read the opening sentence or the opening words. No, yes, no, but it should. My own answer was absolutely not. But you see there is a distribution of answers among both scientists and philosophers and people in other fields. Why do I maintain my religious faith, not just in spite of all of the wonderful natural explanations of the phenomena of nature, but really because of it? And one of the reasons is that I find that the more that I study nature, the more I look at the history of people having studied nature, the more I see that nature is not complex and ugly, but in fact, nature is simple and beautiful. And the reductionism that Jean Stone referred to in his talk is actually, for me, one of the reasons why I embrace religious faith, because it's very difficult for me to understand how it would be possible to have such beauty and simplicity and fine order in nature without there being some sort of intelligence behind that order. So the fact that Maxwell's equations in the upper left of just 4 equations, which with a little bit more sophisticated mathematics can be reduced to a single equation, describe everything about electromagnetic phenomena. And Newton's laws of motion and of gravity describe so many things in very simple equations. We're going to return to Schrodinger's equation in just a few moments, but I want to emphasize that this argument that I make to myself is not something that I consider to be a proof of the existence of God. In fact, there are many scientists who know about these things just as well as I do, and they have come to different conclusions. But in fact, I say that I don't believe that it is possible for science to prove the existence of God, but I also insist that it is not possible for science to disprove the existence of God. This existence of such order is nevertheless something that is strongly suggestive. There's another suggestive feature. Now, I don't know why I can't advance my slides. There we go. So here's another suggestive feature. This is a portion of the table of the fundamental constants of nature. You see on here Newton's gravitational constant, the mass of the electron, the mass of the proton, the fine structure constant. It turns out that these constants of nature seem to be fine-tuned for our existence. If the fine structure constant, I am told, were a little bit different, maybe 10% different from what it is, we wouldn't be here to ask why, because our body chemistry wouldn't work if the fine structure constant were a little bit different. And we know of no reason why the fine structure constant should be what it is. So one possible conclusion is because God made it that way, because God wanted people like us to exist, people who have consciousness, people who can be in relationship with God and with one another. But there are people who come to very different conclusions. There are people who believe that there are 10 to the 500 different universes, all of which have different values of the fundamental constants, and we just happen to be in the one where we could be, because how could we be in any other one? So again, this is an example of something that, for me, gives a very strong suggestion that there is some intelligence behind the universe, but not a proof. But nevertheless, some people have been convinced by this. Antony Flew, a philosopher, who for his entire career was a very strong proponent of atheism in his philosophy, toward the end of his life, when presented with this idea of fine-tuning that I've been describing, in fact changed his mind and wrote this book in which the apparent initial title is "There is no God," and the "no" has been crossed out and replaced with an "a." And what I love is the subtitle of the book, How the World's Most Notorious Atheist Changed His Mind. Well, it makes me think that perhaps he found God, but he did not find humility. Well, okay, this clicker doesn't seem to be working, but we'll just carry on. Okay, so I want to be very careful, though, about the meaning of this kind of argument. We see the fundamental constants are fine-tuned for our existence, and we say we don't understand why this is so, and so it must have been the work of God. Now, the trouble with that kind of thinking is that you ascribe to God the things you don't otherwise understand. But the history of the world, the scientific history of the world, has been such that we continue to understand more and more, and so if you ascribe to God the things you don't understand, your God becomes smaller and smaller. I refuse that kind of an approach. To me, every discovery that explains something indicates a greater glory for God, because it indicates once more how God has it all wrapped up in this wonderful simplicity and order. I should probably say something about this idea about simplicity and order. I have to admit that this is very much a physicist's point of view. If you ask a biologist, you might get a very different answer. In fact, I have asked biologists, and a lot of biologists would say their view of the world is that it's rather messy and ugly, whereas the view of physicists is that it's beautiful and simple. It's perhaps one of the reasons why I'm a physicist. So a little bit more about why I embrace religious faith, and that is that, or at least why I'm not bothered by any kind of a conflict between science and religion, and that's because, in general, for the most part, religion and science address different kinds of questions. Galileo famously said, saying he was quoting one of his friends, that religion teaches us how to go to heaven, and science teaches us how the heavens go. And I think that while that's a very clever statement, it's actually a good description of reality. I think that in general, science tells us things about how things work, what was the sequence of events, and those conclusions are based on observation and experiment. Whereas religion answers different kinds of questions. What is the relationship of God to God's creation? How should we behave to one another? And it's based, at least in part, on other ways of knowing, on faith, on revelation. And there are certainly overlaps. These are not two completely separate and non-overlapping fields, but the areas of overlap are quite important. Take, for example, the question of climate change. I believe that the scriptures tell us that God has given us this world in which we live with the expectations that we will be good stewards of this world. Science tells us that we are failing at that stewardship and gives us some indications about what we can do to improve that. I think that the convergence of these 2 points of view is very important for the survival of life as we know it on this beautiful planet. So now let's talk about quantum mechanics. How does its revolutionary implications for even something as fundamental as what is real affect religious thought? Well, remember I promised you something about Schrödinger's equation. This is an extremely simple equation to write down. It's not such an easy equation to explain. It's an equation for determining the nature of this function psi, and that function psi tells us everything there is to know about the behavior of the quantum object that it describes. Say, for example, an electron. But if you ask me what it is, I don't know. I know that it behaves like a wave. It oscillates back and forth in time and in space in the same way that water waves do, or light waves are electric and magnetic fields that are waving back and forth, and water waves are water that waves up and down, and sound is pressure of the air that is waving back and forth. If you ask me what is waving in this equation, I have no answer. There is no reality, so to speak, to the wave function. And in fact, there's at least 2 senses in which the wave function is not real. You may notice that there's an I in front, the square root of -1, the base of the imaginary numbers. So this is not a real number. But more than that, it doesn't represent some real thing. If I square this, that is, if I take its complex conjugate and multiply it by the wave function, then it tells me what the probability of finding an electron at any given place is. But that still doesn't tell me what is this thing called the wave function. What is the physical nature of it? We don't know, but we use it all the time, and we use it to wonderful effect. We use it to explain all kinds of things. In fact, most of our modern technology comes from understanding Schrödinger's equation and the wave nature of electrons, and we wouldn't have things like our cell phones and our consumer electronics if we didn't have Schrödinger's equation to explain how electrons work. But we still can't tell you what that wave function is. I can't explain so many things about the nature of quantum mechanics. We'll get into entanglement in just a moment, but I want to emphasize how successful it is. It's not just a matter of having produced a wonderful technology. I can calculate properties of nature and confirm that they are correctly calculated to 13 digits. So this is absolutely astounding as a successful theory, and yet I can't tell you what is at the heart of this theory. What is the wave function? So this idea, which is called wave-particle duality, this idea that an electron, which is obviously a particle, is also a wave, is pretty weird, but it has been incredibly effective in producing good results. But there's so much more. Let's consider an electron again. An electron is sort of like a spinning top. And unlike a real top, where the spin axis could be pointed in any given direction, for an electron, if I choose some arbitrary axis and ask what is the projection of the electron's angular momentum along that axis, there's only two possibilities. That seems pretty strange, but that's the way it is. It's one of the things that comes out of the theory of quantum mechanics, that there's only two possible directions, which we call up and down. But here's the really weird part. The electron can be both up and down at the same time, what we call quantum mechanical superposition. Now, we go through most of our lives saying things like, well, you cannot be in two places at the same time. But electrons can, in fact, be in two places at the same time. They can be in two states, both up and down at the same time. They can be in two physical locations at the same time. In fact, the wave function of the electron tells us that the electron is, in a certain sense, in an infinite number of places at the same time. And this is something pretty weird, what we call superposition. Okay, now here's an important point. If you measure what direction the electron is pointing when it's been put into this superposition, you will get one of the two answers. Those are the only possible answers. Now, you might be tempted to say, well, that means once I measured it, you might be tempted to say, well, before I measured it, it was in fact pointing up if I measure up. That would be wrong. It didn't point either up or down before you measured it. The act of measurement, in a sense, brought into being the fact that the electron was up or down. Now, it turns out that you could speculate that there's something you don't know that you can't measure called a hidden variable that tells you whether the electron's going to be up or down, but you don't have access to that information. And if you're only dealing with one electron, that idea sort of works. But if you go to two electrons, we can prove that that idea doesn't work. So here's an expression that imagines that I had two electrons, and one of the electrons is either up or down, and the other electron is either up or down, but whether the two electrons are up or down isn't entangled. In other words, if this electron is up, this one's going to be down, but if this one was down, the other one's going to be up. No one could predict before you made a measurement which of those results would be. But when we measure the correlations between whether this one is up and this one is down, we find that if we assumed that that property of being up or down existed before the measurement, we get the wrong answer. And this is what Alain Aspect and his colleagues got the Nobel Prize for. This just sort of describes how the experiment worked. These three gentlemen got the Nobel Prize for doing the experiments that showed that that was the case. That you could not have what is called a hidden variable theory. In fact, what's called a local hidden variable theory, that asserts the reality of the existence of the spin being up or down before being measured. It emphasizes in a very strong way what Bohr taught us, was that what we learn about in physics is not what is, but what is measured. Now, a warning. These features that really question the nature of reality, because what could be more reasonable than to say the property of something exists before we measure it? That's the way it is with all of the ordinary things that we deal with. Einstein said, wait, do you mean the moon is not there when I'm not looking? Well, of course, the moon is there. And for any macroscopic object, these questions of reality don't arise. But when we go to the submicroscopic level of atoms and molecules and electrons and photons, then we have to grapple with this idea that reality is not what we thought it was, that reality is not the kind of reality that we became used to in classical mechanics. So this is often considered to be part of the weirdness of quantum mechanics. Einstein was so offended by this idea that he called it spooky action at a distance. But in fact, it was Einstein's insights that showed just how strange quantum mechanics was. I think most people didn't really realize how strange things were, but Einstein did. Einstein is sometimes seen as a kind of an enemy of quantum mechanics, but in fact he was one of the architects of quantum mechanics, and certainly the people who brought to our attention this really strange idea of quantum mechanics. It took John Bell several decades later to make it so that ordinary people like myself could understand the strangeness of quantum mechanics in this regard. But anyway, what does all of this have to say about God or about religion? Well, some people have come to the conclusion that the connectedness between what happens when you measure in one place and measure in another place that could be very far apart in principle, that connectedness that we call entanglement is some sort of validation of the oneness of nature that is a common feature of Eastern religion. So that is one way in which this idea shows up as a religious feature. Let's see. I'm trying to figure out where I am now. Right. Okay. So the other thing is that this whole idea of entanglement it's certainly non-intuitive. It might seem to some people even to be illogical, but it's the truth. It is the way things are. And to me, it represents a mystery of physics. I don't know of anyone who's been able to explain why entanglement works the way it does in a way that makes contact with my understanding of classical physics. And so, for me at least, this feature of physics remains a mystery. So many aspects of religion are also mysterious. And in some way, having these features of quantum mechanics that are themselves mysterious makes me a bit more comfortable with the mystery that is related to religion. Here's an example. Before quantum mechanics, everyone would have thought that it was a completely reasonable question to ask, where is the electron and how fast is it going? That sounds like a perfectly reasonable question. We know, because of quantum mechanics and because of Heisenberg's uncertainty principle, that if we know where something is, then we don't know how fast it's going. And if we know how fast it's going, we can't know where it is. And so that means that question, which sounded so reasonable before we understood quantum mechanics, is in fact not a valid question. To ask where is the electron and how fast is it going is not a valid question. We can ask, what is the range of positions where the electron is? What is the range of velocities that the electron has? But we can't ask the question, what is its position? What is its velocity? Even in principle, no matter how good we get at making measurements, we cannot answer that question. It's not a valid question. There are many things in religious faith where we ask questions that seem to have no answers. And while I don't think that you need quantum mechanics to understand religion, this connection, this fact that quantum mechanics presents me with clear examples of things that are mysterious, makes me feel better about the kinds of mysteries that are evident in religious thinking. So There's often a lot made about the conflict between Einstein and Bohr. They were good friends, but they were often in conflict about the meaning of quantum mechanics. And if two of the greatest scientific minds of all time, which I certainly think they were, couldn't agree on something as fundamental as what the meaning of quantum mechanics is and what the nature of reality is, then perhaps it's not surprising that we can't figure out questions about religion. Now, this debate between Bohr and Einstein has been largely settled in favor of Bohr, although there are lots of people who still argue and speculate about so-called interpretations of quantum mechanics. But I think that one of the things that quantum physics teaches us is that our naive intuition that properties exist independent of whether we look at them is simply wrong. And in some sense, when we look at a quantum object, when we measure something about that quantum object, we bring the properties of that object into being. So let me say that one more time. The properties of the object only exist as potential. And when we look at the object, when we make a measurement, that in some sense we bring that property into being. This makes me think about our Creator speaking our universe into existence. Not, again, that you need to understand quantum mechanics to understand something important about God, but I think that it makes it more palatable, perhaps, especially to physicists, to understand that the kinds of things we believe in the religious sphere are no more unreasonable than the kinds of things that we understand in the quantum sphere. But in spite of all of this, there are plenty of people who are going to claim that there's nothing besides the material world, and in particular, that there isn't any such thing as knowledge that is gotten by any way other than the scientific method. Well, the great physicist Freeman Dyson, one of the architects of quantum electrodynamics, a part of quantum mechanics, had something to say about that. Dyson said that science and religion are like two windows that look out on the same reality, but from different perspectives. And there are some things that you will see from the religion window that you cannot see from the science window. And there are some things you see from the science window that you cannot see from the religion window. And there are some things that you will see from both of those windows, but with a different perspective. And I really love this analogy, and I think that it even is worth expanding it to imagine that there are lots of different windows that we use in our experience of life. The windows of art and music and love. And I don't think that even the most devout atheist wants to live life looking through only one window. And so to me, it's a very good argument that you should take seriously the idea of both the science window and the religion window. So we're coming to the end of this talk, and you might think, well, this guy has it all figured out. Absolutely not. I am full of questions and doubts, things that I don't understand. Why do innocent people suffer if God loves us and wants the best for us and is in control? Why do we have such a wide variety of religion? How does God interact with the world when the faithfulness of God is evidenced by the stability of the laws of nature, and yet we believe that God interacts with nature? How does that work out? So I expect that a number of these questions are going to be the subject of further discussions, and if you ask me about them later on today, you may get different answers from the kinds of answers that I would give right now. especially if you give me good arguments for why I ought to think about things differently. And so we come to the end, but it's not really the end because we've got lots and lots of discussions yet to go in this meeting, and I'm very much looking forward to all of those discussions. Thank you very much.
Un grand merci. Thank you very much. Thank you very, very much for this talk. On a été beaucoup de chance d'entendre cela. Je pense qu'il y a 4 ou 5 choses essentielles à retenir. La première, vous avez vu qu'il vous a parlé de cette dématérialisation du monde. Donc je mentionnais en introduction, on l'a bien vu avec lui, cette dématérialisation, le fait que c'est finalement quand on parle de la réalité, on tombe sur quoi? Une fonction d'onde. Ensuite, vous voyez le premier dessin de Luc, le réel c'est ce qui résiste à nos représentations, surtout quand on peint mal. Donc la première chose, c'est vraiment cette dématérialisation du monde. La deuxième chose, c'est la superposition. La superposition, c'est quelque chose d'incroyable parce qu'une porte, si elle est ouverte, elle n'est pas fermée. Si un mur est blanc, il n'est pas noir. La superposition, la dématérialisation, la superposition et ensuite l'entanglement, l'intrication quantique dont il a longuement parlé, qui est cet état très mystérieux qui effectivement est aussi complètement impensable dans le monde où nous sommes actuellement.
L'intrication ou l'entanglement, c'est un cas spécial de superposition.
Voilà. Mais encore plus étrange parce qu'il est à 2.
Oui, absolument.
Et ensuite, ce qu'il nous a dit, qui est très très important, je trouve, c'était sur la question que nous sommes, d'une certaine façon, nous faisons venir à l'existence la particule élémentaire et qu'on peut imaginer cette idée que aussi Dieu fait venir le monde à l'existence et cette insistance qu'il avait sur le fait le mystère en science et le mystère en religion. Et pour terminer, je mentionnerai aussi qu'il a mentionné Al-Haytham dans son exposé. Et j'ai oublié de vous dire que Robert Cohn, dans son fameux article dont je parlais tout à l'heure dans Nature, mentionne aussi Al-Haytham. Et c'est quelque chose qu'on ne fait pas assez en Occident, car Al-Haytham est vraiment un des très très grands esprits scientifiques de tous les temps. Et il a fallu que je travaille avec des amis musulmans, moi, pour le découvrir. On ne m'a jamais appris ça à l'école. Donc c'est important aussi de rendre ce crédit à la tradition et à la science musulmane. Encore un grand merci, Bill, pour ça.